Hello guys, welcome back to the channel again. Today we will solve the 24th question of June Leetcode challenge. So the question is unique binary search tree. What we have to do is we have given a number and we have to identify how many unique binary search tree can exist which have the number of nodes equal to n. Suppose if we have to count for n equals to 3, what are all the possible combinations? So if we do one node here, one here, one here. So this is the first combination. Second combination is this one. Third is this one. Fourth is this one. And the fifth is this one. So there are 5 combinations for n equals to 3. First is this, second, third, fourth and fifth. So we have to identify how many possible unique structures of binary search tree can exist where n equals to 3 or n equals to given n. Suppose if n equals to 2, so how many possible combinations are there? Suppose n equals 2, then how many possible? One element here, one element here. So this is the first. Second is this. So for n equals to 2 we have 2 combinations. Suppose for n equals to 1, what we have to find? So suppose if we find out for n equals to 1, so it will be one node only. So there is only one combination possible for n equals to 1 node. Now if we try to find out it for 4, it becomes a bit complex, but we'll try to find out using structure only first of all. Then we will see some sequence and then we will try to do something with that sequence and find the next value. So if we try to find out all the combination for n equals to 4, we found first combination will be the root node, it's left, then right, then left. For the second combination, root nodes left, right and right. Third, root node, then it's left, then right, then one left. So it have 2 nodes. In this, all the nodes are at the left or followed by left nodes, left, left, left. So this is the fourth combination, and this is the fifth combination. First left, then right. So these 5 combinations are there when these 2 values are fixed, or these 2 starting value nodes are fixed. Means in this also these are fixed, in this also these are fixed, in this also these are fixed, so in this also these are fixed. For n equals to 4, we have these 5 combinations in which the root nodes left is fixed and we have 5 combinations. So similarly for right also same 5 combinations will be there. So till now what are the value? 5 plus 5, 10. And if we found all the other sequences, means these mean 10 sequences we got. And what are the other sequences? If we have root nodes left, right, and then this left, root nodes left and right, so 2 combinations are there. And for similarly for right also 2 are there. So this will be 5 plus 4. So there are total 14 combinations for n equals to 4. So till now what we have found? We have found the combinations for n equals to 1, n equals to 2, n equals to 3, n equals to 4. So if we write their sequences, then what will be some observation, or what will be the Q observation? We will write that observation. So before looking at the discussion part, what we will do, we will first try to find out that what thing we have to use in this, and with the help of observation then we will calculate some values. Now what concept or what algorithm we have to use in this? We must use DP. Now why we will use DP and how we have find out that I am using DP, or how we will find out that in this question DP will be used. So suppose in this question we have to find out the number of combinations. Now number of combination is somehow dependent on the number of combinations of previous. So if we have discussed for n equals to 4, that above 5 patterns are again repeating for one more time. So somehow DP is using there. So if we have to find out combinations of something, 90% of times dynamic programming will be used. So in this also we will use dynamic programming. And for dynamic programming, we all know we have to first initialize every index of the DP array, and then at the end we have to calculate the final DP index with the help of previous all values. Now in this case, first of all we have to initialize DP's initial index. So for that I am initializing DP 0 index equals to 1. Now we have find out for DP is 1. So for DP1 we have x equals to 1, we have 1. Now we will not start considering DP out there, because first of all I will explain you the observation, that what observation we will take, and then how we will apply the dynamic programming on it. Now after that, for n equals to 2 we have 2, for n equals to 3 we have 5 combinations, for n equals to 4 we have 14 combinations. Now if I want to find out for n equals to this, then what I have to do? Simply what I will do, I will multiply this by this and this by this, and I'll add both. So 1 multiplied by 1 plus 1 multiplied by 1, so it will be 2. Now similarly, if I want to find out for n equals to 3, what I will do, I will multiply this by this by this, and multiply this by itself only. So what it will be, it will be 2 into 1 plus 2 into 1 plus 1 into 1 over 1 multiplied by 1. So what it will be 5, because 2 plus 2 4 plus 1 5. Now if I want to find out for this, what it will be, 5 multiplied by 1 multiplied by 5, so 5 plus 5. So after that, 1 multiplied by 2 multiplied by 1, so what it will be, it will be 2 plus 2. So what it will become, it will become 14. So I find out for n equals to 2, I got correct answer. For n equals to 3 also I got correct answer. For n equals to 4 also I got correct answer. So now if we try to find out it for n equals to 5, what it will be, I'll multiply this by this, so it will be 14. Again I'll multiply this by this, it will be again 14. Again I'll multiply this by 5, so what it will be 5. After this I'll multiply 5 by 1, so it will be again 5. Then 2 will be multiplied by itself, so it will be 4. So what will be the value? Value will be coming 42. And now if you search on Google, or if you try to find out all the combination, it will be coming 42 only. Now what our array will be upgraded to? Array will be upgraded by 1 1 2 5 and 14. So our final value, this final value will be our answer for every index. For n equals to 0 we have this answer, for n equals to 1 we have this answer, for n equals to 2 we have this answer, for n equals to 3 we have this answer, for n equals to 4 we have this answer, and for n equals to 5 we have 42 as answer. Now if we want to calculate for n equals to 6, it is also easy. We'll multiply this by this by this, 14 by 1 1 by 14, 2 by 5 and 5 by 2. So using this we will find out for n equals to 6 also. So now we have observed something, that if we multiply our initial index by last index by and if we start iterating from I equals to 0 or I equals to 1, if we subtract this value, means if we calculate multiply this by this by this and this by itself, then again this by this by this, and finally this by this, so we will get the value. So what we will do, we will start from I equals to 0 to I equals to n minus 1. So starting will be I equals to 0, then 1, then 2, then 3, then 4, and I'll multiply that index with dp's n minus 1. So 1 will be multiplied with last index, 2 will be multiplied by last second index, third index will be multiplied by third index only, because if the length is 5 minus 2, we have 3. Similarly, in reverse also, for n equals to 3 it will be this index and this index, for n equals to 4 it will be this index and this index. So using this we will find out our solution. Now if we see my solution or code, I'll explain you first that what I'm doing in the code, and then we will submit the solution. Then we will check the time complexity, that how much time it is using. So this is the solution for this question. Now first of all, for what I have done, I have initialized this dp with all its value by 0. Then after that I have initialized its 0th index by 1. Now I have before only initialize first value, because we all know that for n equals to 1 we have only one combination, so we have initialized this. Now after that I have asked for unique BST with int n, in which n is the number which we will get. Now after that I have initialized count equals to 0. Now I have started iterating over these whole conditions, and in this also I am using recursion, and in this also stack will be created. So now if you don't know anything about recursion and stack, you can see my previous video. Now if you don't want to see that video, I'll explain you a bit in this video also. So what I am doing is, I am just first, if int n is coming, then I am first calculating all its previous value. Suppose if n is coming with n equals to 4, so first of all I have calculated n equals to 3, n equals to 2, n equals to 1, and then at the end I have calculated this n equals to 4. So what if we are trying to traverse this array, or if we will make a stack, what it will be? So we have first initialize n equals to something, n equals to 4 first of all. Then I'll initialize dp. So dp is 0 index, or sorry, dp is equals to 0. So dp will be initialized initially by this. After that it will be initialized with 1 and 1. So after that what is initializing? We are initializing count. So count will be 1. Sorry, count will be 0 initially. So I have now started iterating from I equals to 1 to n. So I equals to 1. So I equals to 1 initially. Now what I will do, I will check this first condition. Now first of all what I am doing here is, I am checking that if the value is previously calculated, means if we have initialized this array, then we does not require to do all this stuff. So here only I am checking that the previous value is initialized or not. If not initialized, then we will initialize that values before. So if the values are initialized, then we will directly multiply that indexes which we have used in explanation part. Now suppose in this case we have I equals to 1. So the first condition we will check here, dp is 0 index, 1 minus 1 0. So dp 0 index is equals to 0 or not. So it is not equals to 0, it is 1. So the condition becomes false. Now what will be? dp is n minus 1. So n is 4, 4 minus 1 3. So n equals to 3 is equals to 0. So we have dp 3 index is 0. So the condition becomes true. Now what will happen? I'll initialize dp's n minus 1, means dp's third index by the value. Now for that what I have done, I have called this unique array by n equals to 3. So again what will happen? This will be start with 3. Before that recursion stack will be created. What will be there in a stack? This condition, this count condition will be there in stack. Count 1, we will initialize this by count 1 only. So after that what will happen? Here I have initialized this. Again this count will be again initialized with 0. I will be again initialized with 1. Now again the same condition will be compared. dp 0 index is 1, sorry, dp is 0 index is 1, so it is not equals to 1. So this first if condition will not be true. Now we will go to this second if condition. So we will check that n equals to 3 here. So 3 minus 1, 2. So 2 is also 0. So now again this next part, or this dp insertion part, will be go in stack. So I'll initialize it with count 2. Now after that what will happen, n will be initialized with 2. Now this condition will be again checked, or first of all this count will be initialized with 0, I will be initialized with 1. So in this part is initialized. Now after that what we are comparing this thing, that I equals to 0 or not, sorry, I minus 1 is equals to 0 or not, dp is index. So in this case dp's index is 1 and n is also equals to 2. So n 2 minus 1, 1. So this is also not equals to 0. So now count will be initialized. So count will be initialized with 1. So after that what will happen, this loop will be incremented and I will be equals to 2. So 2 minus 1, 1 will be there. So 1 is also not equals to 0. Now after that this condition means n minus 1, n minus 2. So n minus 2 equals to 0. So this is also not 0. So count will be incremented to 2, because 1 multiplied by 1, 2. So count will be equals to 2. So after that this loop will be over. So count will be return. So dp's n minus 1 index means this index, this n equals to 2. This will be initialized by 2. So till now we have executed this condition, and now this, before doing this count 2 will be popped. So now what will happen, so the previous count, what it is, the count 1, sorry, count 2, count 1 will be there of the n equals to 3. So sorry, n equals to 4. So we are executing the loop for n equals to 3. Now we will check for n equals to 3. So count is here 2. So we are considering the count 2. So we will multiply what all indexes, we will multiply I minus 1, means this for what we are checking for. Here we have I equals to 1. So we are checking for the count 2 value, or for n equals to 2. Here we have I equals to 1. Now what we have done, we will multiply this 2 by 1. So what it will be, 2 multiplied by 2. So it will be 4. So this will be initialized by 4. Sorry, this will be initialized by 2, because 2 multiplied by 1, it will be 2. So after that what will be the value of I will be 2. So 2 minus, we will check this condition first. So 2 minus 1, so it will be 1. 1 is 1 here. So this value, this will be not called. After that this will again check that n equals to 3. 3 minus 2, 1. So both have value 1. So this will be not executed, this both if. So after that what will happen, so this count will be incremented by 1, because 1 multiplied by 1 plus 2, it will be 3. So after that I becomes 3. So what we will do, we will check again this I equals to minus 1 to 0, means, sorry, what we will check, we will I equals to 3, I minus 1, it will be 2. So second index is 2, it is not 0. So this condition will be not become true, and we will not call this function. Now after that this final value will be called n equals to 3. So n equals to 3 minus 1, n equals to 3 minus 3, it will be 0. So this 1 and this 0 will be multiplied, plus 3, it will be 5. Now what will it return? It will return count. So count here is 5. So after that this value, so previously I have called this count, means I have called using this condition, means I was on this condition when I called. So first of all this will be initialized. So this will be initialized by 5. So after that this count 1 will be there. So this will be popped from the stack. Now our stack will become empty. Now we will execute it for n equals to 4, and I previously it is equals to 1 only. So first of all we will calculate the values for this. So count will be what? Count will be this value 1 multiplied by 5, it will be 5. So after that I will become 2. So again if we check this these both condition becomes false. Now again count will be incremented by count 5 plus 2 multiplied by 1, so it will be 2. So after that again this loop will run, I will be equals to 3. So 3 for 3 again this both condition becomes false, so 3 will multiply, or these two indexes will be multiplied. So 2 multiplied by 1 equals to 2. So after that again this loop will run, I equals to 4. So after that this 5 will be multiplied by 1, so 5 multiplied by 1 again 5, so it will be 5. So 5 plus 2 plus 2, it will be 14. So a count will be at the end 14. Now if I want to insert, I can insert, or if I want to directly return the value, in this case I directly return the value, so I can directly return also. So this will be returned to our main function, and then that function will return the value. So now if I submit the solution, so I got correct answer. So the trickiest part in this question is to find out the sequence, that which sequence we will get and how we will get the sequence, and what all values we have to multiply or add to find out our solution. So if you want to know more things about DP, I have made videos on dynamic programming. If you want to view that all 5 questions, I will be attaching that in my description. So for that you can check that playlist of dynamic programming. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.